All right, so I'm gonna do a little bit of a brief intro. I made a little slideshow set to music that will help set the tone. I think it's fun. I did it all with Claude. For those that don't know me, I'll get into it a little bit more, but my name's Josh. I love computing. I have for 2.5 decades or more, basically since I first played with a Toshiba T1600. It had 20 megabyte hard drive and the slowest modem known to man, near as I can tell. But I was like 9 or 10, I thought, wow, they can talk to each other. Isn't that kind of neat? And then later on there'd be chatbots, like AOL Instant Messenger chat services rather. And then, we'd do video on the internet. That was pretty wild. So to be here today talking about where we're at with the amount of inference we can host locally, it's better than Star Trek, to my mind. So I will get started here. It says press spacebar to begin, and I'm about to do that. Hello, Jerry. Being my own hype man.
Are we buying this from you?
No. I'm trying to tell you to buy a Mac. So I will fault Claude only ever so slightly, because that was supposed to line up at the perfect. So we're off by about 30 seconds. But what I'm about to show you is the weirdest thing I've found in computing in a long time. Of course, every week I get a new thing to pair that with. What we're looking at now is the idea that you can spend $600 on a machine that could rewrite the Linux kernel 8 times, I forget what. It's so damn fast. Like the amount of just raw output you have on this is pretty impressive. Now, part of this is based off of some of my dissenters and skeptics might say, well, an Opus token is way better than whatever shit token this is. And that's true, unless you're better at presenting on it. Okay, now, or using it. So, I'm losing points for showmanship because I have to turn. Okay, so self-hosted. So APIs are fucking great. I love Claude Code. It's fantastic. Can do a lot with it. Open Code brings a lot of that same functionality there. Pretty neat. This is not a pitch against paying for your favorite frontier model subscription. In fact, it's a way of saying that's the only thing you probably need because it's a harness for local inference. You might say, hey, I don't understand that yet. That's fine. I've got a lot more to say. So the question is, are these tokens actually worth a damn, right? We say, okay, well, that's a lot of friggin' tokens, but can they actually do good output? So this is me. I'm an infrastructure guy at heart. I say if you can't build on your own metal, then it's not really yours. I like sovereign infrastructure. That's one of the things that really irritated the shit out of me with LLMs when they started hitting the market is I got forced into an API environment. And in an API environment, there's doors that are closed. I really don't like that. I had an ambitious goal I didn't reach for today. The ambitious goal was to offer my own private API service for all of you. But there's only 168 days in a, or 68 hours in a week, and I couldn't quite get to it. We got close. All right, so I did a lot of benchmarks. So for me to have good benchmarking, one of the things that I want to have is two machines that are different enough from each other where I can run the same test and see if there's differences. So my fast machine, that's the polite way of saying it's this dumber model, is a demon. That's what I call it. It's a 16 gig Mac Mini. It runs pretty fast. What it can do pretty well. The unit economics on it make a lot of sense, but if you can't actually get useful output, then does it matter? So the next class up I have is what I call the Bruiser class, and it's just another term for the Mac Studio M3 Ultras with 96 gig of RAM. They have more RAM and faster unified memory bus, so they can do a lot more, a lot faster. But a recurring problem and a question I will leave for the audience at any time, feel free to reach out to me on LinkedIn or elsewhere. What do you even do with this much horsepower? We've never really had it before. So I tested a bunch of different things. Oh, I also have an M4 with 24 gig of RAM. For those that are thinking, I've never self-hosted, what does all of this mean and why does it matter? And you might even think, I've heard of RAM before. It's on my phone, it's on my computer, it's on servers. Why does this matter? Well, video RAM is the really exciting stuff. And if you want to do we'll double back on this later, but if you want to do like a really complicated thing, generally you'll need more RAM because the conventional rule is more parameters of model, which takes more memory, equals better output. So the Frontier models are running at 9 gorillion parameters. Most of you on your hardware at home, you could probably run a 1 billion parameter model. Gemma 3's model came with only 8K context. So in a world where Claude's shipping with 1 million context, 8K isn't super useful. We'll get on this some more, but I did do some benchmarks. I found there's a lot of use for a lot of these things. But the big takeaway from this slide is just, I tested a bunch of different machines to see with different configurations where things excelled and where they didn't. Okay, so we've got that. Economics on it are pretty wild. If you think about a Mac Mini, we've got a $600 machine and it has 16 gig of video RAM and an OK processor and OK bus speed. We've got 120 gigabits a second. The M3 Ultras have 800 gigabits a second, so they're not the fastest, but it's pretty damn fast. If you compare that, I've got an RTX 5080 based system. If we go to the NVIDIA type of technology, undeniably it's faster, 2 to 3 times faster. What it can do, it can do. However, with NVIDIA, you're very, very limited on RAM. A GTX 5080 based system cost me $2,500 versus a 16 gig Mac was $600. They're hard to get. Maybe you're going to pay $700 for one if you're getting one. Okay, but pretty significant amount of compute. I will make a note that Apple did release an 8 gig MacBook, the MacBook Neo, and it has last year's iPhone processor. It still runs some small parameter models pretty well. So if you've got an 8 gig video card, you're going to have, if you've got a video card, you'll do a lot more throughput on it. But yeah, so this is roughly what we're comparing. So we say, and it's not using anywhere as much power. So if you have one of these things at home, it's not drowning you out of your Zooms. Then we get to the Bruiser class here. Oh, I love these ones so very much. I've got another one coming this week and I'm super excited. So at this, we can get to give you an idea, just to compare it to some Frontier models, OpenAI came out, they said, hey, I have think OpenAI 4.0 mini. That's roughly, you could do that around, some people say at an 8 billion parameter. I think that doesn't make any sense. But sticking within the OpenAI family, they released GPT OSS 20 billion parameter, which doesn't quite fit on some of these smaller machines. And the 120 billion parameter, you can run both on an M3 Ultra with 96 gig of RAM. So you can get a pretty, 4.0 mini, you guys might want to shit on the model that I fell in love with in this process. However, you don't have to go all the way to a Frontier model to get outstanding results. You do need to be super organized. That's really where a lot of the punchline on self-hosting versus Frontier models. If you have your Claude, your Codex, it's going to do a lot better with abstract instructions versus if you're self-hosting. But yeah, the other thing is you spend $4,000 on the RTX 5090 or GTX or whatever the hell it is, the 32 gig one, and it is faster. But for example, if So Google just came out with the Gemma 4 models, which are a pretty good reasoning model. You basically, you'd be at limit just about running that max resolution model on a GTX 50, RTX 5090, whatever that is. And so in this type of environment, the $4,000 Mac actually gives you access to deeper level intelligence than you would be able to find otherwise. Spoiler alert, the smarter it is, the more horsepower it takes. So, you will get more tokens out of a smaller model with a beefier machine. But to even ride the ride, you got to be to a certain size. So raise your hand if you understand the memory footprint of an LLM session. All right, we're going to fix that. Everyone here's going to learn that. I'm sorry if you didn't come to learn, you're going to really dislike this. So starting point, we're going to have a session. We go hello to the model, right? Hello, Claude. It loads the model. The model is very large. For a lot of the better models, we're talking 20 to 50 gig. Some of the higher parameter ones might be literally hundreds of gigabytes. And then when you say, I have a question for you. So you put in your system prompt, you give it your prompt, you say, how do I make ice cream? On that turn, it runs through everything on the model, and then it gives you the output. Then on turn 2, it does all of that again, plus whatever you asked it to do. So it is incredibly memory intensive, and that compounds the longer you go with it. So by the time you're at the 10th part of the conversation, it's just like talking to a human. If I talked to you and we exchanged 100 sentences back and forth, around sentence 100, you'd be like, I don't remember the third one. This is largely how AI works. If you've got 16 gig of video RAM, your cap is 16 gig. So if the model's 14 gig, you don't really have any room to grow. All right, now I know I just asked you guys the same question, but we're going to see if this stuck a little bit. I'll give you even more framing here. Basically, it's heavy to load, and the more you use it, it just gets more heavy. So show of hands, who has some idea of how LLM memory footprint works? Now, okay, a few more hands. Good. For everyone else, I'm sorry. That was probably not the best part. So if we think about a model as like a layer of, like a wedding cake, right? We've got a 10-layer cake. Every time you have a request hit the model, it goes through layer 1, then it goes through layer 2, then it goes through layer 3, and so on and so forth. It has to touch every one. As you might imagine, this is very inefficient. So I came up with this clever idea. I said, if every time I talk to it and I do a turn on a conversation, it becomes exponentially worse, right? It has less of its memory available, less attention, all of these other things. Why don't I just on the back end grab the inputs and the outputs, just store that in a stupid database, flat text file, something stupid, and then start as if I'm at turn 1 again? Well, this would surely solve the problem, isn't it? Oh, that's interesting. If you find that interesting, there's more good stuff. Now, there's this thing called mixture of experts. Mixture of experts says, well, this is stupid. We've got 10 layers of the cake. We're only talking about science. Let's only grab the layers that are talking about science, or something similar like that, some logic like that, and says, let's only send it through there. So what ends up happening is you get all of the benefit of a larger model's attention, but then it's cutting out thinking about French art when you're trying to solve TypeScript build errors. And so what I found is, you'd think the sales pitch would be a 3 billion parameter model that uses 1 billion, it's 800 meg. But I'm just going to call it 1 because it's easier. That's only using 1 billion. Does it run like a 1 billion parameter model in terms of your memory? Or does it run like a 3 billion parameter model? The answer is, it's friggin' fast. So this is the Granite 3.1 mixture of experts. It's a 3 billion, or is this the 3 billion? Yeah, 3.3 billion goes down to 0.8 basically. So you end up getting a lot of the speed. So this is a model that performs super, super well on a Mac Mini. So all of those tokens I was all excited about, you guys could code over all of the internet, again, 10 times a week or whatever, all of that. It's based off the idea that this is a super efficient model that is trained to do business use case. I cannot believe that I'm sitting here talking about AI and talking about how relevant IBM of all companies is. But Granddaddy Big Blue strikes once again. This is a pretty significant model to have available, and it does pretty good. All right, so benchmarks. All right, for those that might question the legitimacy of the research that was done, I put the names of files that stored the benchmarks. Of course, I could make up the files myself, but I tried to document it. Okay, so all of these benchmarks you see on LinkedIn, you say, oh, it scored this many points on this, scored that many points on that. Oh, okay, we're super excited about all this shit. But like, what does it mean for what you're doing? Like, I'll give you a sidetrack here. With Gemma 3, that at an 8K context is a piece of shit model by comparison. It's as expensive computationally to run as IBM's Granite 3.1, which has 128K of context. And on top of the 128K of context, it's pretty smart. So you can actually feed it entire code bases and say, answer this, can you help me with that? And you can load enough context in it for it to really understand something. So when we did when you're looking at this, so I took, for example, some common WordPress processes I have. I currently admin, most of them are dormant and maybe neglected, not all of them, about 170 WordPress sites. And I did some benchmarking and I said, well, because I do strange things, I said, what if I gave the AI access to my production environment and said, go make me a WordPress website, and then go update, take off the default content, and then go set a theme. And basically from the starting point I said, I'm just going to assume it can do whatever I ask it to do and wait for it to tell me otherwise. And then what it told me is, initially I went, well shit, out of 10 benchmarks that we had set of things that we care about, that we measured, it failed at 8 out of 10. It was only 2 out of 10 success rate. You go, yeah Josh, that's what I knew. It's a stupid model. Puh. I love the energy. However, with better instructions, within 2 more rounds of testing, we got to 10 out of 10. So what I will say is the skill cap on the small models really is if you're giving it good directions, because that and that alone is what it will do. And as a theme, the smaller the model is, the more it'll go, for example, a smarter model, you can say, here's a fork, go stick it in the electrical outlet. It'll say, I don't know that that's a good idea. It thinks, not Gemma. Gemma 3 just says, okay, boss, and shoves it in. So if you're in an environment where you like compliance, the small models that are cheap to run are actually much more obedient. Now, they're dumb, there's still that. However, within certain functions, like they're excellent. And for example, the Gemma 4 series, they have some smaller models that are designed to run on edge devices where they took this mixture of experts idea. They call it effective parameters. I don't know what the difference between active and effective parameter is. I'd like to think they're all effective, but okay, I'm not the guy selling that. Yeah, so here's some details about what I did. Basically, when I took a look at the hardware, I said, there's a few things that matter. Now all right, I'm gonna do a show of hands. Who identifies, at least in part, as a hardware guy? All right, we're a dying breed, but we're more relevant than ever. So I said, well, these machines have different speeds. So I had a business where I did a lot with MySQL, and I learned a lot about the limitations of, well, what if it's in RAM versus doing indexing versus normalizing versus structuring and decoder keys and all of this other stuff. And so what I did is I said, I've got these different types of machines, and so if I can measure the same transaction across it, I can get some insight. One of the insights I found is that the context window, yes, it's partially driven by the model, but it's also largely driven by the hardware. Of note, the Granite 128K model, I took to a 2 million context window without the model failing. I don't think it was doing good work, but with Gemma and its 8K context, it would straight out fail well before we even got there. So with the right hardware, you can push it. On some of the smaller models, on the M3 Ultras, I got, we'll call it, I got up to like 1 million context for free on pretty good models. And so when you say, okay, well, where does this fall off? You've got, okay, so that's our RAM. Then we've got our threads on our processors. And so what I did is I did concurrency testing. And I said, well, if we do it concurrent, what I found, we'll get it, there's a matrix for it, but like these are the sorts of tests I did. I said, let me take the same transaction, run it across different hardware, see where it falls off, what it does. I made some custom tests. One of the things I said, hey, say I'm StreamRift and I have a software engineering company and I manage WordPress sites and blah, 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 and basically buried 7 to 10 threads of that prompt into a single prompt, and then we did 10 to 100 turns and said, what does it remember and how does it remember it? A lot of this was done with curiosity, saying, instead of me trying to shove this into doing what I want it to do, why don't I just, as a starting point before we get to that, say, what are you already good at? Like, what do you follow well? What do you understand? And the answer is quite a bit. Yeah, so here's the differences of the different models. So the fastest one by far is the IBM Granite mixture of experts. 188 tokens a second is really quite something. Because if you think about the amount of, like, just again in terms of lines of code, that means like these machines can do, like in aggregate, my cluster can do about 200 million lines of code a month. And I don't even know what to ask it to do. And we know it won't work, but like at some point, so like I guess we ask it to review its code. And it's like, well, how do you do that when it's going to write like 20 versions of software while you're sleeping? Just how do you steer the damn thing? So yeah, so and this is just on the Mac Mini. This is a $600 machine. It's nothing exotic, and you can get some real good quality work out of it. For those wondering, you can set it up as an MCP server for Claude, so you can actually have Claude call it, or you can just take Claude. Hey Claude, I have this model, you can do all these tokens and use it as an extension. So like for example, one of the things I did was I took my email and I downloaded it and I said, let's look through all of this. So I had a separate session go through and summarize each email and make a database of the summaries. And I didn't have to pay any API fees for that because it was just local inference. Now doing a review of any of that, I'd want a better model, a sharper model to do it. But if you think about the way that just the structure of work is, once I need a function that does X, Y, and Z, or however you're doing it, that could be an instruction that's handed down. So think about it, the mental model is the frontier model is managing the other models. Yeah. So here's some nice stats. The Granite 3.32 billion parameter model, it's not a mixture of experts. It did seem like it was better, but like, this is also the single concurrency, I think. Generally, a machine's going to be able to do 2 to 4 times in parallel in aggregate, meaning if I say, here's one request, it might do 100 tokens a second. If I say, here's 2 requests, it might do 130 aggregate, so it's lower per thread. But that largely tracks with the amount of processing cores you have on your CPU and GPU. So you can, if you run these tests, so like what I did is I said, hey, run a test. Run it from 4K context to 128 8K context and see where it dies. And I said, wherever it dies, now let's run that across concurrency up to 16. And on some of these tests, it got to concurrency 128 and it was still climbing. I suspect it would be inadvisable to do more transactions than probably 80% of the cores on a machine, assuming some of the cores are being used for other things. I did make my $4,000 MacBook crash 3 times in a row before I realized what I was asking it to do was making it crash. So I would suggest throttling and leaving some space on there for, apparently the computer's entire existence isn't just for LLM. This is it, right? So we go from 99 on a single concurrency to 188 on the same machine. So almost 200 tokens a second of a pretty good model for $600. Who's paying $200 a month for Claude Code? Yeah, we spend on these things, don't we? All right. Yeah, here's just some more comparisons about them. What was very surprising is that the speed of the IBM model was way better than the Gemma model for the same size. In terms of your compute, you're largely just dealing with however many billion parameters it is. It's just, that's going to be the footprint of it. Almost just like saying it's going to be a gig, it's going to be 4 gig, it's going to be 8 gig. And then just to put some numbers on it, if you've got a 10 gig model, each turn it might go up by 500 meg to 2 gig, depending on what quant you're using of it and some different things. So like, it grows exponentially. So we'll get into some neat things here. All right, so. Yeah, I got rid of some models. GPT OSS 20 billion parameter was a pretty good model. The 120 billion, it was just too sluggish to run. So it was a little better, but like, side note, I didn't put this in here. I tried to run a model that required 3 machines to connect to each other to run it. And in 14 minutes and 30 seconds, we found out that 2 plus 2 was 4. So, not all of this is good. I'm showing you guys some of the nice things. I spent an hour figuring that out. That was not my favorite. There's different categories of things that we'll ask it. So in terms of, this is a part of why I say build your own tests. Part of build your own tests is also build your own pre-coaching. one of the things that I've been doing very heavily with AI coding is having knowledge repositories here, there, and everywhere. So when I'm starting a clean context, I can have a high signal, very dense, here's what we're working on. So as an example, in our infrastructure environment, on our machines, we run Apache and Nginx, and they love fighting with each other. And Claude hates this. And since what we do is off the beaten path, we're not doing the typical hosting infrastructure, it has to learn from scratch what this is every time. So if I was sensible, what I would do is I would put together a nice little guide about, hey, by the way, AI, this is how we deal with this. So largely it's an Nginx caching issue. It's a very straightforward thing, but it takes it like 4 back and forth to figure out something that's repetitive. So when you're doing your benchmarks and trying to set it up, you're gonna have a lot better success with it, right? So are we solving for, are we gonna put up some graphic on LinkedIn and say, hey, isn't this neat? We did some cool things. Or are we solving for actually making something useful in our day-to-day here? Yeah. So, yeah, these are the hard numbers on the Gemma 3B 1 billion versus the Granite 3.1. It's just embarrassing for Gemma. Now, to be fair, Gemma 4 came out and it blows a lot of this stuff out of the water in a lot of different ways. But that's sort of typical of what we're looking at. So if you're hearing, oh, these new models came out, the biggest, if you're thinking about, well, what does that mean to me? Think about if you've got a machine with a video card or you've got a Mac, how much video RAM do you have? If you've got a Mac, M series or better, which is most of the more recent ones, then the amount of RAM you have is sort of the hard limit on what models you can run. Now, your machine will get hot. It is actually doing something. I would recommend if you're doing self-hosting that you probably don't plan on running the machine on it 24/7. I do like leaving a lot of stuff overnight to run. However, if you haven't gotten to know your machine ahead of time, you don't want to wake up to it melting or burnt out or even just restarting. That's annoying. Dun, dun, dun. So one of the nightmares of that tax that you pay, the KV tax, every turn in the discussion, I said, and I mentioned this before, well, what if we just store it in some dumb text? Wouldn't that be nice? So this is the math for the nerds out there that are really into this. Basically, by turn 10, you've lost like 90 to 95% of the attention that the session has. And by turn 100, you've probably just outright failed on it. You might notice Claude likes to auto-compact. And they say, would you like to summarize from before? That's basically what this is. I call it the StreamRift KV hack. It's a name, it's a thing I came up with, and then I found something neat. So, premise is basically, if we do this, then by not going to turn 100 and not paying that tax, we should do better. And so I tested that with GPT OS S20 billion parameters, and it worked. And that would have been a fine time to stop looking at it because the world made sense then. Because then I kept doing testing, and this concept that should be as basic as math and gravity did not hold. So I tried on a mixture of experts model. And Granite apparently has already solved this KV tax problem with its model, because every time I did this more sophisticated thing, it was like a little better and then it got worse. And so whatever they're doing in those active parameters is helping address this issue. So essentially it found a very clever nuance to something, made one model better. So you say, well, okay, but does this matter? Hey, Josh, why the hell are you saying this? Well, what this means is that GPT OS S20 billion parameter model, you can run on a Mac Mini. Normally by turn 2 or 3, it wouldn't work. But if you compress the thread, you can actually run it basically flat indefinitely on hardware that normally you wouldn't be able to manage this at. So that's one reason why it's kind of interesting. Yeah, and here's the numbers. Like, it was actually running this test, the SKV thing, with Qwen 3.54 billion. It actually was 9.6% worse. I don't even know how it's possible, but like, it made me real curious. All right, so when you're looking at this stuff, choosing the right architecture really matters. Most of you, for whatever you're doing, if you haven't played with it yet, if you actually have some understanding of how code works, you probably would do great with this Granite model. Now, there's tons of other models. There's other models of similar class. I've been picking on IBM because I've sort of fallen in love with it. They have some newer models, the 4 series. They go all the way to 256K context. I took that to 2 million parameter or 2 million context from a hardware perspective on the Bruiser class, but I wasn't able to get, but like, yeah, so honestly, yeah, like big win is give it good instructions. So if you've ever looked at somebody and they say, I'm not going to read write a paragraph to it, that person, like, you got to write a paragraph to it. And what I'd actually suggest is going back and forth with it a bit, because it's not hearing you the way you think you're making sense. So you're like, go do this thing, and it hears something else. Yeah, so there's that. Okay. Yeah, so not all of this is good news. Not all of this is good news. So if you think about context, some of these models, you're going to die out. If it's a smarter model, you might die out at 4K context. Now, that's enough to measure a lot of stuff, and if you make it useful, if you just set up some local Postgres database, some Node script, some Python, whatever, grab whatever your favorite language is, and make some sort of a harness for it, you can probably consolidate a lot of your stuff down to a smaller context than you might think. I was looking at it from the perspective of, if I said no compromise, I want to have full context, what do I get? And the sweet spot is around the 20 to 30 billion parameter model on those M3 Ultras with 96 gig of RAM. And I can get like 200 tokens a second on a good model between a couple of them. But what I've found is optimizing the dumber models is actually a much more high value piece, and it does help you avoid a lot of the problems. So when you do the KV hack, it helps with this a lot, because you're not burning the context on every turn exponentially. So if you're compressing it, a more advanced way of doing it, or a different way of doing it, is actually when you go turn by turn, instead of just putting all of the prompts in one JSON blob or whatever you want to put it, if instead what you did is you have it do a summary. So think like you've got all of your output from your turns of conversations, and you're at turn 10. Instead of repeating everything that happened, just run one session across it saying, summarize this, and then pass it forward. You can basically keep the KV tax. You can basically hold it off indefinitely that way. So again, depending on your use case, it's helpful. If it's more broad, not so good. If it's more focused, definitely a lot better. Yeah, and this is a very common curve. So if you look at the top left, that's like my most baby test. It's the 4K single concurrency. The C is for concurrency. And then at the far right, it's 128. And then the far bottom right, it's 128K context. So this is the power curve. So like, for example, if you look at C4, it's almost the same right all the way down. So that means the memory footprint isn't hurting us. And what we're seeing is that I think that machine has a 10-core processor. So it's bottlenecked because it's only using 4 processors. So you start to see at different points it'll fall off. But like basically whatever machine you run it on, you're going to see some graph like this. This is how I would recommend testing if you want to play with something locally and you just want to have something easy to do. Hey Claude, I want you to install this, however you want to do it. And have it test, I call it a context sweep, so 4K to 128K, where does it fall off? And then a concurrency sweep, okay, so when we try to do that across however many times, and it should be, there's some relationship to your RAM, and then there should be some relationship to your cores. So if you've got a 10-core chip or a 10-core GPU, I wouldn't go above 8 unless you are okay with the fact that it might crash your computer, you might need to restart it. It's otherwise fine. But when I have this matrix on all of the different machines, it made it really easy for me to tell, okay, so the cost for inference on this is here, the cost for inference is here. At 96 gig, you get, so if you think about spending $4,000 on an NVIDIA-based machine, you're going to spend $4,000 for the card and then maybe another $2,000 on the hardware. Even if it was just the card, you can't do GPT OSS 20 billion. You just can't because it won't hold it. You get like 2 or 3 times the RAM for the same amount of money. Now it is slower, but like the NVIDIA can't even enter the ring. So this is just some visualizations of what that looks like. We're talking about on one of those machines, it's 1.5 billion tokens a month, which is just wild, just wild. So then if we spread it out, right, across, per day, per week, it's just a pretty impressive, like, if we think about like how useful a code editor is, right? Code editor with Git, we can track as we're changing files, we're not using file folders anymore. Now we're like saying, hey, I go write this stuff, and it's managing its own context. It's managing like, I never really wrote documentation before. My documentation's beautiful now. AI does a great job writing all of these notes in there. So what I found partially in a lot of this was a lot of the tools that are designed right now. So like, for example, you could take, if you're saying, well, how do I actually do anything with this? Josh, this all sounds interesting. Obviously, you're super excited about it. There's a browser extension for VS Code Cursor. You can also do it command line. It's called Cline, C-L-I-N-E. And if you download Olama and you run anything on your local machine, you can connect them. So you can use it like a cursor agent, just running off your local hardware. Now, the smaller models are too dumb to use tools sometimes, but it's still pretty fun. And then like there's also open code that works a lot like Claude Code. But a part of this is there's just different categories of things to do. So like, for example, where I'm actually at now and thinking how to apply this in our stack or at my company is, why don't I essentially put the code on the cloud, right? Put it up on our infrastructure, we've got a private Git repo, and just have autonomous agents just going through and proactively bug fixing, proactively documenting, proactively iterating, proactively whatever. So we're really steering these super engines now. And so like this is like, you might, oh, how do we get it? $600, cheaper than a lot of laptops. It's crazy. All right, math. Yeah, so you can similar to so I was talking about the Granite 3.1 mixture of experts model, and it was basically a 3 billion model that went down to 0.8 billion. Quen has a 35 billion that goes down to 3 billion. So you get like the brilliance of a 35 billion parameter model and only have to pay the KV tax of a 3 billion parameter model, which means if you can load it, like if you're saying, well, what do I take away from this, Josh? These mixture of expert models, what does it mean? It means if you can barely load it, you can probably actually use it. That's sort of the difference there. So if you're looking at how much video RAM you have, just as a simple back of the napkin math, figure out whatever video RAM you have, half of that, that's the size of a model you could go looking to run, and it'll probably run pretty efficient. If it's bigger than your RAM, it's going to swap with disk, and it's going to be unusable. Yeah, there's downsides. These are commodity boxes. It's not error correcting RAM. It's not redundant power supplies. It's not in a data center. But it's $600. Buy two. Right. So for those that are wondering what your decision path is, there's some detailed notes about this. I won't spend a ton of time on it, but like a part of this is the quant of the model. So even within these models, you think about like compressing an image file, you lose some resolution on it. There's the full resolution model, but then you get down to smaller versions of it. Q4 is where a lot of people end up, and it is not going to be as effective. But for example, let's say you have a 16 gig Mac Mini, right? Okay, you got $600, go buy this. Take that $600, you got your box. Now you can probably run the full resolution of these smaller models, and if they're well organized, they'll be more coherent. I did notice between, if there's 10, call it there's 8 tiers of quanting, around tier 4 or 5, it's fine. I found no real difference in the overhead of us running it between the full resolution and slightly better than full resolution, but there was a lot more memory requirement. So generally you're gonna probably, if you can, like Q2 is terrible, Q4 is pretty good usually, then there's 6, then there's 8, full resolution. But yeah, so if you wanted a lot of the real nerd discussion on it back there, hopefully I gave you enough time to read that. If not, maybe you took a picture. But yeah, so in GPT-4o equivalent, if we take a look at what I have, this is $50,000 a month API fees, uncensored, unrestricted, unlogged at home. I can do whatever I want with. And any infrastructure latency nerds in the house? No? 1, 2, okay. So if you're doing this, you can beat the cloud. You can do more concurrency requests. And the other thing is you can chain your LLM input and output in the unified memory. So going back to the Bruiser class, the M3 Ultras, they have 800 gigabit a second of bandwidth where they can run these transactions. As soon as you hit web, anybody that's on an API base, like it just falls off a cliff. Like they're not even playing the same game. Like you're just spinning circles around them. So that's another edge for it, if all of this is not too much of a pain in the ass. Yeah, so I do let my guys play with this. I will say I'm a little offended. I set up API service for them. They tested it. They said it worked, and then they didn't use it. So I yelled at them later. I said, why? I build you guys super clusters. And they said, well, we want to use OpenCloud. Okay, I'll set up an OpenCloud interface for it. Great. So solved that. I am working on, my goal for today was I was going to try to offer the API service on this. It got a little hairy. I got almost there. With another week, I could have done it. But I set up a chatbot on it, and what's going to be kind of interesting about that is opposed to ChatGPT and Claude, where they log all of that stuff, we're not even going to have it on our hardware. So the way the software works is it stays in local storage on device, so that way you send the request to us, we send back the response, we forget about it, because I don't want to pay for storage. I'm trying to make some money. And then you got some privacy. If you can at least trust me to be greedy, then you have privacy. All right, so we did some stuff here. Okay. Yeah, so there's a lot of stuff I haven't tested yet. I'll be honest, one of the things that was pretty cool, Monday, I'm onboarding a new engineer. All of the engineers on that project, there's 3 of them, I all met here. One of the things that's really neat about these community events and being able to talk about these different things and different sessions like this is being able to actually like tease out ideas. I'll pick on Fady. He told me about something really cool. Strix Halo. They came out with a way to say, you can buy a 128 gig machine and not wait like back order on Apple on this stuff. Now it's slow, but you can have it now. That's pretty cool. I also found out he used open code, which solves some problems for me here. And so all that to say, if any of this you found interesting and you have questions you're curious about, I will put up my QR code and my contact info. Like, feel free to hit me up on LinkedIn. I do love talking about this shit. Or I walk around, say hi. If you're working on something cool, like it'd be neat. What's really strange to me is when I started doing the benchmarking on this versus where I got now, like they're different worlds, and it's not even been 30 days. So Lord only knows what happens next. Yeah, that's the find me. All right, so questions. We've got a young, now I'm gonna do the grumpiness. You gotta have the mic come to you. So if you have a question, feel free to raise your hand and a mic will come. Oh, I've got one up in the back. You're the next contestant on Price is Right. Oh.
In the far back?
Yeah, I've seen a hand.
You have to speak loud, it doesn't magnify.
Oh, okay. Well, yeah, thank you. Also, great presentation, walking through the numbers and the cost expectations of it. And looking at it from like a scalable, like corporate model, a lot of companies are going towards trying to do internal LLMs and things like that and not even really knowing the depth of this technology. So for someone that's working there, what would be like something I can potentially say to grab the minds of the right decision makers and know we need to be more analytical about this rather than we'll go with this company, go with this company. We have to know the layers versus, I think you said something of experts, MOEs
Mixture of experts,
versus other models and such.
Yeah, I mean, it's a great question. I mean, I'll say this, and I don't think there's a humble way to say this. I don't know, the Venn diagram of people that have the expertise on hardware and AI and like sort of look at these realms, it's a small group. Like later today in the programmer meetup, Matt Denman will be presenting, he's in that group. I know I'm not in a circle of one, but in terms of where we're seeing the business use case for this, what you're just describing is one of the groups that will lag on technology just because they're more deliberate, more sensible, measured. And these are like the bleeding effort, like excitement. So what I would say, so if you're in some, I'll give you a boardroom soundbite. Part of it is self-aggrandizing. You don't have to use that. But you could say, this weekend I went to Tech Alley in Las Vegas, the greatest city in the greatest country on earth. And I met this really smart guy who has a software company that helps businesses leverage local AI so they don't have to worry about security breaches and they can leverage all this stuff. This is boutique-y, individual, one-on-one stuff. It's not going to be like a service that gets offered. It's part of sort of the death of SaaS. One of the things we're seeing is, especially for larger enterprises, like just to give you another interesting use case of something that wasn't before possible. Imagine you've got a 100-employee company and you've got all these emails going around. You don't know who's fighting with what. We don't know what's going on. We have no sensible way of reading all of these emails. But you grab a couple of these boxes, you get it set up, you get it looking through, you can go through the read-only on the mail servers. Now you can track a lot of stuff that's going on in your enterprise and provide help and assistance where it's needed, and also find out when people are just wasting time and whatever else. So did I 30% answer your question? And if not, what's left?
No, just to close out, you definitely answered my question, especially with the first point. They are the slowest moving whale because they move slow and precise, but it went from a year ago, no one can touch AI, you'll get fired, HR will, be in your inbox, you'll get walked out the building, to why are you not using the models? Or how come you didn't run this through Copilot? So they're rapidly trying to adapt because of all the changes happening around them.
Yeah, and I'll throw on that too. A lot of corporate companies, I'm going to pick on Notion, and any of them are fun to pick on, Canva too. They're slapping low computationally burdened process automations. But if, for example, just to put numbers on it, like if you're a company and you have, $1 million a year that you're spending in staff, right? You spend 10 grand on some hardware and some nerd, maybe another 10 grand to set it up. You're in a different category of company. Like that's one of the biggest things I've been seeing from my end. Like I've probably in the last year, I've had at least 10 different engineers do at least one project with me. Currently I have 3 or 4 full-time. We're moving at speeds that we just, like, I've got the hold my beer approach on it. I tell the guys, like, we trust the AI, write the code, and then have it bug fix it. Like, our typical process is, hey, AI, I want to make a thing that's like this and that. And we say, okay, now design the front end. Okay, now build the back end. Now test it. Now build it. Like, that's like 2 days. And so all that to say, I think the companies that are embracing it internally early are going to be the ones that are going to really like outlast their competitors, because we're not seeing it be get rid of the employees. We're seeing it be the employees can do so much more for so much less. Let's maximize it. I've never been making more money in my life than I'm making right now. And the cognitive load of pressing 1 and 2 after I've done a deep dive with something is a lot easier. And so what I'm seeing is these benefits get passed on to companies. And so the actual, like, I do applied engineering, like academics, fine, but like what actually makes things better? And so like the more companies that embrace that, like, yeah, like they're killing it. It's a good time to have a little risk appetite and a couple of bucks. I guess I'll tell you one other thing, another sales pitch for it. It's cheaper than they'd think. Like the numbers I was talking here, right? I've got a $200 a month Claude Code plan. For me so I spent, call it 40 grand on hardware. I've got the equivalent of $500,000 a month of API fees. Like, the equation's weird. All right, we have another one right ahead of you, Tom.
You can go.
Oh,
Hi, thank you. So when you were flashing through your slides just a bit ago, one of the things that I saw that jumped out at me as a project that I'm trying, that's why one of the reasons why I'm here for the self-hosted thing was something you're working on that said super RAG, which that's what I would want this kind of self-hosted model for, and being self-contained for some kind of RAG on large stale company data, so that you can ask questions and things of that nature for. Have you gone any further down that rabbit hole?
Oh yeah, I live in rabbit holes. They're so fun. Because then there's other rabbit holes and other rabbit holes, and I work with smart people who also like going down rabbit holes. So one of the things that was interesting about this, so just timeline and walk you through my mindset. I bought the first NVIDIA-based system. I come home, I go, oh, wife, I bought my first AI computer. I'm super excited. And then like a week later, I bought a Mac Studio. I go, why the fuck did I buy that NVIDIA? Like, Jesus, how bad was this?
One of the Sparks?
No, it was a GTX 5080 basis. It's a nice machine. It's got 16 gig of RAM. It's fast. I shouldn't throw shade at it. It's a perfectly usable Dota computer. Where it got weird was, so I did the math on the tokens per second. I said these Mac Minis with these small hard drives, $600. I get, call it 200-300 tokens a second on a cheap model, 256 gig hard drive. And I just ignored that the hard drive was there for like the first month, honestly. Then I went, well, wait a minute. I could put a fucking database there and it'll be fast, right? Because I'm thinking infra, like put the data right where it's getting processed. That'll be the fastest. And so I said, well, we've got that there. So yeah, like we have Postgres databases running on these boxes. We have file storage on them. So it's weird because it's almost like I'm expecting to find more challenges down the road. But like the architecture of like these Mac Minis with the M4s, I can do a Thunderbolt. So it's a cheap cable. It's a $13 cable. I can plug it into either other ones so they can share RAM, which you pay a horrible tax for it, but you can do it. But also they transfer it like 40 gigabits a second. So if you're doing like an ETL pipeline, so imagine you wanted to run a process where you wanted to do super customized personal emails to your customers, right? It's a common thing, right? Specific. You could literally have it start a session. The system prompt is, you're an email drafter for a company that loves its customers, and here's all of our history with this customer. Draft a message that can go out in the email. That's going to be super personalized, and it's going to be computationally cheap. You could do a gorillion of those a day on a $600 box. Yeah, so all that to say, like, I've been looking at it from the perspective also of anything that I can do with a script, I'd rather do with a script because it's computationally cheaper than running inference. And so I'm relying heavily on tool calling and just scripting. So that way, yeah, the combined amount is just, I can't even wrap my head around all that can be done. Oh. Behind you.
Oh, behind me? Okay.
I know.
Okay, I'm just gonna preface this and say, like, I drink the Microsoft Kool-Aid, right? Like, I work from.
That's fine. It's great.
It tastes really good. Whatever. I build copilots, right? So it's hard to understand how something like this, where it costs a lot cheaper, but like at what level, I guess, enterprise or structurally, what company size is somebody gonna come and say, I'm gonna run a couple small machines versus like using something like Azure or a cloud-based service to say, hey, I can target SLM this way and still have the security and all that built in. I still have, M365 where I can read all of my emails like you're saying and all that. So I think I don't know, at what point, where's the line, right? Like, where's this like a local stop versus like an enterprise build?
So I'm going to give a cop-out answer. It's both. One of the things that I've found generally with engineering is, of any kind, hybrid solutions are usually better. So when we're trying to make the fastest car, it wasn't a gas engine, it wasn't an electric engine, it was a gas and an electric engine. So there are a bunch of companies that converged on it. Maybe it's changed since, I don't know. What I've found, like one of my real aha moments was, I will always want Claude Code, probably. It's so fucking fast and smart and does so much. And it's a perfect harness for all of this other hardware. Once we're getting into the bigger class, I mean, part of the problem is a lot of, okay, I'm going to be less charitable for a second, I'm sorry. A lot of the security risks are self-imposed by using cloud. So let's say I'm a law firm and I have a case file and I want to read through it, but I don't understand it. My client doesn't want me to pay me $300 an hour to read 1,000 pages of text. If it's on a local box, it can't get pulled up in Discovery. If it's being read through locally, it just can't be touched. So a lot of these security stuff that you need, like you could airlock it so it doesn't even have access to the internet. It can run that level of local and private. So I think what we're seeing as a shift is we're getting away from cloud and SaaS, and we're looking at more local. And like that's been sort of the move on some infrastructure, but what's interesting is a lot of sort of the web database, all of those sort of folks, like they're so used to cloud, it's foreign for them to build local. But, if you take a $600 box here and you can, run all of your transactions on it, and you've got a nice little Azure account for a few things, you do some things, you got your Outlook account, you're keeping things away, that's all right. But I think that's like the solution for now, is keep what you got and then add what gets better. All right, we got another one down here and one over there.
Do you want to do next,
And
Josh?
also, we're at almost noon, so if anybody wants to leave to go eat, that's fine, but I'm also here. I had croissants.
Hey, so my question should be kind of easy. I have a 4080 Super, and I just do, I only have one box. You allude to having multiple boxes in your home lab, or it's not a home lab, it's a production lab, right? The question, I don't work with Macs that much, but you have them all networked together. Did you say you have them networked together through the Thunderbolt to share the VRAM?
Yeah, so you can do that. Going back to and I'll bring up.
Like, I guess my question also relates to just to let you know, like, how do you manage all of the nodes together, so to speak?
I have no idea. I'm still trying to figure that out. It's so much horsepower. To be less facetious, okay, so if you were splitting it from machine to machine, there's 10 layers on the cake. Each machine has to have a full layer. So you could have 5 machines, each takes 2 layers, and you go chain on it. You do take a speed bump every time. The least penalty I felt on this was I think it was Llama 70 billion, which would technically fit on one M3 Ultra, and I ran it in parallel on two, and I took a 6% haircut on the processing speed. But it gave me a lot more room for KV and for text. So that was sort of the trade-off. But like you can layer these, it just gets real slow. That's how it took 14 minutes to find out 2 + 2 = 4.
Yeah, because the NVIDIA infrastructure is different. Like if you have multiple GPUs, like you just like NVIDIA SMI, it'll show you all of the GPUs together. So
Yeah, like well, and this is all local, like meaning like,
yeah,
hi
no,
machine.
I was just that's why I was
Yeah.
saying like I was curious how you orchestrated it.
Yeah.
I have a reply for that. Yeah, I have a reply for that. In fact, I'm a design lead at ExoLab and exolab.net, and we have a solution to manage cluster on Apple Silicon or other hardware.
Oh, well, okay. How convenient.
Yeah.
Yes. Down here, my friend. He's been waiting a while too, by the way. That's all right. Frenchmen can ask things too.
So kind of the key to the local is these instructions that you're using. So what does your process look like for making good instructions? Do you do anything like self-improvement, or do you have like the frontier model say, all right, give this some simple instructions that it'll be able to follow? But what's your process look like for making those good and better?
Yeah, so it's counterintuitive. Being more detailed is better. I do like using the frontier models for it. So what I would do is I would say, like, for example, we were doing WordPress install command line stuff. So we said, hey, make a test. Here's the things that we're solving for, meaning I want to be able to deploy a WordPress site. I want to be able to clear out the new stuff. I want to be able to set the time zone, install a theme, whatever. So I would have it design the scripts and then test them. Like, it's super iterative, but you actually frequently, like the small models, believe it or not, it's not use short sentences and small words. It's be explicit and detailed. And also, try to not tell it everything. Try to just give it a clean lane. You're writing a function. Here are the variables. One of the other things that's very helpful is just making a project Bible. So I start off a session, I say, look at the project Bible, here's this. Just think like the more focused you are with them, they're gonna do exactly what you're saying. And the North Star, as much as we might not like this, you're not as clear as you think you are. And it's going to punish you for that. It's not the model's problem. You're the problem. That's what I've been telling myself a lot. That's the internal voice. All right, everybody. Those are some great questions. How about a round of applause? Thank you. All right, everybody. Well, until next time.